Yeah. Aircon.
Where's my telephone?
I ate it.
Where's my telephone? It's charging. Okay. Thank you.
Oh, this one. Oh, Lord.
Where's the microphone for this? I feel bad if people hear me talk.
It's fine. The people want to know. They want to hear you. Okay. Finishing up with question 3. Finishing up with question 3, we're supposed to show how to find the residual. We did that over here. Residual equals 9 from the chart minus a predicted value of 13.412. 13.412 is the number we get after we substitute 3 into the regression line. Hello. Okay, and then of course the residual calculation is a simple thing. It's just actual minus predicted. So here we have 9 minus 13.412. That gives me a residual value of negative 4.412. And in keeping with what we were talking about, a negative residual means an overestimation. You see that here. We estimated 13, the actual was 9. That's an overestimation, giving us a negative residual.
Could you do like 6 equals, and then the like 6 equals 6 minus 5.36 plus 2.8684 times 0.5?
Yeah, algebraically, anyway, that's equivalent. I think your 6, you meant 9, though.
It has to always be 9.
Well, no, 9 because
9
that's
because, well,
that's
we
the
use
actual
9 and 3
value.
because that's one coordinate.
Yeah.
And then the next coordinate's 0.56.
Yeah, so if you substituted that in,
Yeah.
it would work the same way. I'm not going to tell you how to do your algebra.
Yeah,
know.
but it works. So
Yeah.
you can do that.
If it works algebraically, that's what it works. Okay, as far as plotting the residual plot, all right, this is again a small number of coordinates. There are only 5. It really isn't a bother to do the entire residual plot and then plot it by hand. Not do the residual plot. Put the residuals from your calculator into list 3. So I think we can demonstrate that now. Let me clear it out. We'll go to list 3. You know what? I'm going to go backwards a little bit. I'm going to go ahead and first of all run the regression line. Shoot. Run the regression line. Stat. Calculate. Linear regression. L1, L2. Calculate. And that gives me these values. And the reason why I want to use the linreg right now is because my calculator only creates a residual list after you use linreg. So if the residual list doesn't exist, it means you have to use linreg. So we're going to go over now to my lists. Now that I'm assured linreg or the residual list exists, scroll up to L3, put in the name residual here from the list menu. That is list number 8. And those are my residuals. Okay. Now the residual plot is nothing more than the X list, L1, against the residual list, L3. So really, you could do it by hand, estimate all of these values, and you would get this chart right over here. For example, if we take a look at the first one, we have 3 and negative 4.5, approximately. So we're going to go to 3, Negative 4.4 is right here, and you just put your square there. I like using squares instead of dots. I recommend you do the same thing as well.
Why?
Yeah, it's easier to see. And if you use a square, you actually have a little bit more room for error. We'll do the second one too then. The second one is 0.5 and negative 0.7. 0.5 is here, negative 0.7, that's about right here. So I'm good. Yeah.
What are the different patterns of a possible residual plot? There's fan and none?
Yeah, what you'd be looking for is either a fan, a curve, or a line.
What does it look like?
Curve would look like a smile.
What would a fan look like?
So it's either a fan, a curve, or nothing?
Yeah.
A line. What's a fan look like?
Oh, a line. You could look like a line also. A fan is where they start off, the residuals start off close to the x-axis, and by the time you get over here, the residuals are far away from the x-axis. So it really doesn't look like a fan. Like, well, I mean, it does look like a fan, but it looks more like a trumpet. So,
Okay, like
yeah, a fan pattern would be like this. If you see that kind of a shape. That's the same thing. That's a trumpet.
And then a question, do you remember how you told us it was alpha F4 if you wanted to resid?
Alpha F4.
What was
Yeah,
it?
no, I was wrong. That's to get a Y. That's to get Y.
Okay. Oh yeah, Y1 is alpha F4 though?
Yeah.
It's not letting you do that. And then if you want to get residual, how would you get it?
Second list or second stat, and then
Okay.
it's at the very bottom there.
7.
Okay, that brings us to question 4. Oh, no, I'm sorry. There's one more thing here. Does your residual plot confirm or refute the choice? So the scatter that we see here is unstructured. Be careful not to see structure where the structure does not exist. There's no fan, there's no line, there's no curve. This is pretty much no pattern. So since the scatter does not show pattern, since it's an unstructured scatter, our choice of linear regression is not refuted. Basically, it confirms the linear regression.
I'm confused with like what exactly is linear regression.
The entire process of fitting a line to a scatter plot. Adam?
So if there's a line that's also problematic, only if there's no pattern whatsoever, then it's not comfortable.
Yeah.
So if there was like a fan or something, you could write our choice of linear regression is refuted.
A fan means that the linear regression works better for some coordinates than other coordinates. So a fan or a horn with the bell on the right side would mean that the linear regression works for low values of x. And a fan or a trumpet with the bell on the left side means that the linear regression works best for large values of x.
If it was, let's say, positive, so what would you say then?
For this,
Yeah.
for a residual, you don't have to say anything. You just need to say that because our residuals show a pattern, our linear regression is.
So for finding the regression, like r equals and the r squared, that whole thing, that's when we do stat calc, lin reg a plus px, and then when we click enter, that's when it all comes up on the
Yeah.
calculator.
Okay, moving on to 4. Joey appears to be growing slowly as a toddler. His height at 18 to 30 months age increases as follows. And then we get an incomplete chart that looks like this. And we're supposed to fill it in. So the key equation here is the residual is equal to actual minus predicted. That's the key here. So if we take a look at that first line, the residual negative 0.08 is why didn't the negative show up? Negative 0.08 is equal to the actual, which in this case would be observed, 76.5.
That's also y.
minus predicted. We don't know what the predicted is. I'll leave an X. And then if you subtract 76.5 from both sides, you get, I don't know, 76.58. You get 76.58.
Isn't it 96?
No.
Nope.
The height of the
76.58. So I'll just write it in there. 76.58. The second one, we're going to do the same thing. The residual is equal to actual, which is observed, minus predicted, which is 79.09. And we get a residual of, whoa, that is wrong.
It's just point.
It's just negative 59.
Negative 0.39, right? Is that wheat? Okay, yeah. The next one, residual 0.4 equals the observed, which is unknown, minus the predicted, which is 81.6. So we get x equal to 82. So that means our observed height was 82. Next one. We have residual 0.69 equals actual, which is 84.8 minus x, our predicted. What just happened? And that gives me x equals 80, 84.11.
Yeah, that's right.
Last one here, we're going to use residual is equal to the actual, which is 86, minus the predicted, which is 86.62, giving us negative 0.62.
But it's not. It's asking for the. Oh. On ours, it's filled in. It's the age that's not there.
Oh, okay.
But that you just add three. And it tells us in part E. So or part C.
Okay, next, draw the residual plot. I'm going to do this by hand.
Because we have all the residuals.
Yeah, we just have, no, this is 30 here, right?
Yeah. Because you just add three. Oh, sorry. Yeah, and in part C it's
Yeah. Okay, so we're going to go ahead and make our residual plot. We have an x-axis and a y-axis.
X and Y axis.
Based on what you're predicting.
Predicted and actual.
Oh, sorry.
Sorry, for the 18 age, why is it not negative?
Well, we have the residual negative 0.08.
Oh wait, never mind. Sorry, I was reading.
Yeah.
For the last one that you did, the resid equals 86 minus 86.62. Why did you use the 62? Because on ours it says 62, negative 62.
So what you're saying is I don't need this here, right?
So it says negative 62 and then 30 is missing.
Like that. Yeah.
So how would you solve that? It would just be the normal thing that we've been doing.
How you would get the 30 is from the. Do you see the LSRL there? Height.
Yeah. The predicted height?
Predicted height equals.
Would you
Equals 61.5 minus 0.837 times age.
How did you get that number?
It's given. It's given. Okay.
Wait, how would we know if it's a predicted height or not?
It's because it's a regression line. It should be predicted. Yeah. The fact that it doesn't say predicted is actually a
So we
typo.
don't care about the actual.
No, the actual height is given as
Is
86.
it wrong to assume it's 30 because it increases by 3?
I wouldn't necessarily.
Because other times it's wrong.
Yeah, I wouldn't take a chance like that. So you're just gonna do some algebra. 86.62 equals 61.5 minus 0.837 times x. Again, I don't. We're not really teaching you how to do algebra here, so what you do is not going to be. Did I mess up here? Oh, it's plus. I was like, I'm getting a negative age. What did I do wrong? Okay, let's see. 61 or 86, 26, 25, 25, 1, 2.
Okay, so we would do the algebra and then just solve for x.
Yeah. And I'm sure I'm going to get 30 here. And that's where the 30 comes from.
Residual plot.
Okay, that kind of takes care of the table. Sorry, it's kind of abortive in the middle there. Can we look at B?
Yes.
Let's look at B. We're going to get axes. Here's an x-axis. Here's a y-axis. The x-axis is age, right? Okay. And this is residual age. No, residual height.
How do you know that? That's age.
Our y coordinates are all heights. And we're plotting residuals, so residual height. It looks like my residuals are all between positive 1 and negative 1. Am I wrong there or no? Yeah, all between negative 1 and positive 1. My ages start at 18.
I have a question.
Mm-hmm.
So, since there's two different types of heights observed, could it then you make like this type of graph, like so like that, the height up there, the observed height is down there. Is that what you're doing?
No, I'm making a residual plot. Yeah. 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 Please label the axis for the residual plot. Mhm.
Our data is like not symmetrical. Like what? Like if we can we label like 0.8, negative 0.8, like under the point, just to be thorough. Is that
Yeah,
okay?
that's fine. All right, let's take a look at the first value of the residual. The first residual value is 18 and 18 and negative 0.8. So that's just barely underneath the graph. I'm going to do that in a different color so we can see it better. Negative, so that's right about there.
That's 0.8.
Again, I'm estimating where that is. Negative 0.08. The second one is 21 and negative 0.39. Okay, a little bit further down. The next one is 24 and positive 0.4. 24, positive 0.4. Next one is 27 and positive 0.69. 27, and that's about
30 is
negative 0.62. Thank you. And for all of these, you're just kind of estimating where they are. Do a good job estimate or a fairly good job estimating, but don't drive yourself crazy. This is starting to look a little bit like a fan, isn't it?
And if there wasn't a 30, would it be a positive slope? Yeah, or it's still like a little dip.
A little bit. If the 30 wasn't there, remember we're looking at the residual plot. So the residual plot would have a linear pattern.
But now that it's there, it has a fan.
Yeah.
It's a trumpet.
All right, would you describe Joey's growth pattern from 18 to 30 as being linear?
No.
No.
No? Why not?
No,
It's almost equal on both sides. So
Do you see a structure in the beginning?
linear, then it changes.
Okay, so the linear pattern, or the growth, appears linear for small values of age. But shows a fan shape. Therefore, the linear relationship I can go with that. The answers say that there's no structure to the residuals. This is one of those things where you really don't have a lot of data to go with. So seeing a structure here is kind of premature.
This was just a regular scatter plot, not the residual scatter plot. Would it wouldn't be considered linear? So-
Yeah, this would be weakly linear.
So
There-
the R would be like 0.5 or less?
probably 0.5 and below. If this was not a residual plot. All right, lastly, predict Joey's height at age 20 months. You know, I really should write what this one is. This is letter C, right? Letter D. At 20 months, we're going to have height, predicted height, equal to 61.5 plus 0.837 times, well, what age is it going to be at 20 months? That gives me 78. Centimeters. Yeah.
Isn't it 20 years old, not 20 months?
Yeah, it's 20 months.
And I mean, like, you put 20, but doesn't that make it 20 years old?
All of our data is in months. So it's consistent with the units. All right, that's it. Any last questions for the free response? Sharon?
Okay.
my friend said, my friend wants to know what a residual is. Okay. Residual is literally the actual minus predicted. And again, you can't get a residual unless you have a way of making a prediction. And prediction means from the regression line.
So here's what I get confused about. So I'm very confused when I tell this to find something like D. So like after we find it, we can't just box the answer. We have to write out that blah blah like this is Joey. Like we have to write it like that, or we won't get points for it.
I would like it written out, yeah.
Okay.
Statistics is kind of an applied mathematics. So like bodies or numbers with no meaning, or with
Words mean more.
yeah.
So residual plot is a scatter plot, but it has the residual numbers.
Perfect.
A friend wants to know
Oh,
what's R and R squared. What's the difference?
okay. So R, mathematically, R squared is literally R times R, mathematically.
Is that like the variation?
Yeah. So interpretation-wise, R is an expression of the strength of a linear relationship. Okay. R squared gives you the what percent better is a 2-variable prediction over the 1-variable prediction. So in other words, if I know an explanatory variable, how does that improve my prediction over just figuring out the average?
So what improves percentage of correlation?
No, it doesn't. Not correlation, but predictive powers. There is that phrase that you really need to memorize. That though. The about. Okay. So approximately blank percent of variation in the, what are we calling this, response variable, can be explained with a linear regression relating explanatory variable to response variable. And I know that it's kind of weird just to have that statement because it doesn't feel like it means anything, but it really does. Okay. Over here, for the first part, we're saying response variation response variable. That's, again, the deviations, square deviations for just using the average. And here, linear regression, explanatory to response, that's talking about the squared deviations of using a 2-variable statistics, using a linear regression. Yeah.
Where does R squared come in? Like when are we using R squared? And can you
Like when it asks.
Yeah, you pretty much only need to know about R squared is if someone asks you about it.
And it will say like
what is R squared? Is that what it is?
Yeah, what percentage better, yeah, how much better is our prediction using a linear regression over just using the average?
So is that something that you find from finding the linear regression? Okay.
Yeah.
I guess I
Yeah.
So for like the test or whatever, or any test, would they ask what is the approximate of variation in the response, or would it just ask like what is R squared?
A couple ways. They could ask you both ways that you just said. You could be asked what percent of the variation is explained by using a linear regression. It could ask you what percentage or how much better is using the linear regression over the average. They could ask you, what is R squared? All of that.
Sorry. The only way to find our square is to plug it into your equation, right? Or into your calculator, right?
That's the easiest way of doing it.
But like for us, like that's the
That's the way that you like. If you're starting with raw data, that's the way I would like you to do it. Yeah.
So are you gonna give us like a test question of like the variables, like how you did for Q1?
One more time.
Like how for Q1, those variables were saying like really hard to like the summations and the deliveries. Could you give us?
Oh, I'm gonna try and keep it as, try and keep it so it's not too confusing. Okay. I don't want that to be a reason why you get a problem wrong. But again, I can't measure everybody's how they're gonna get confused with this. It's about 10 and 2.
Response variable would be the dependent variable.
Yes.
So in an example, like somebody's height as they grow, as they age, so the age would be independent, and the height in inches would be dependent.
Perfect.
But then explanatory would be like how much food he eats.
No. Explanatory is age. Explanatory is the same thing as the x variable, same thing as the independent variable. Huh.
Is the pizza here?
You ordered pizza again? Is it Hawaiian?
Maybe someone called me. Can someone go down there? They called me 3 times.
I'll go.
From where?
I don't know. A 213 number.
No, where's the pizza from?
Papa John. Pizza's from the soul.
So there's one pie just for me, right?
I wish.
$10? I don't care. I'm hungry.
You just had a fucking.
I'm hungry.
Remember me and Brandon go out and she orders twice as much as I do.
I mean, I'm always starving at his house. He has like 2 bites and I have like.
I made him 2 batches of pasta one time.
We're gonna get there in a few minutes. So, but resistance just means that outliers do not affect. What I'm gonna do is, we'll see if the pizza's here. If the pizza's here, we'll take a small pause, okay? While we get pizza.
Can I ask you a question about one of the multiple choice run while we take our pause?
Sure.
The number 4.
Mm-hmm.
Okay, so I understand what it's saying that when you have a negative correlation, that means that as one increases, the other decreases, but at the same amount, right?
I've already eraser.
So whenever it says that the correlation is negative 1.08, and then with an exam and the achievement, that means that the higher the exam scores, the lower the achievement, right?
Yes.
Okay, so then.
What's the
So
problem?
then, letter C says students who do best on this exam will be for students, but the answer is E.
Yeah. R has to be between -1 and 1.
Okay. Okay.
So it's like a trick question.
Okay, yeah, because we did this in psych, and in psych, I know that.
I'm
Hi,
Miss
Miss
West.
West.
Have a good day.
Hi, Miss West.
Miss West.
I go to all
Okay, so, but like, let's say it was like -0.08 instead of
Yeah.
the 1.0, then it would be C.
Yeah, I think you.
Okay. Oh, then that makes sense. I understand that.
What is that?
Pizza.
When you find out the lot stuff is very why do you think that?
Do I write my note and then you sign it, or do you want?
You can. Yeah, I'll sign it if you write it.
I'll be right back.
Okay.
Wait, no, it's last
Yeah, those are small. I thought one extra large, one large.
I think this is X one. I think it's too large.
Okay.
Really good.
Where do maybe we should put it over there. Pizza time.
The